Hi everyone, my name is Juba and I'm a postdoc at UPenn. This paper is joint work with Eshwar, Arunachaleswaran, Sampath, Kannan, and Aaron Roth, who are also at Penn. And so today I want to talk about fairness in pipeline decisions. And the reason I want to focus on pipelines is because we know that in practice, decisions about individuals and decisions made by individuals are not made in isolation. Rather, many decisions are going to be made throughout the course of the life of an individual, and those decisions are going to have an effect on each other, and they're going to compose with each other. For example, if I were to look at the education and the job market pipeline, which preschool I'm going to is going to have an effect on which school I'm going to go to, which is going to have an effect on my college opportunities, which is going to have an effect on my employment opportunities. And so one thing that's tricky about fairness in such pipeline settings is that disparities and inequality of access to opportunities can arise at several stages of such pipelines. And then those disparities are going to compose. Generally, my current opportunities are going to be restricted by previous disparities that I have faced. Or if I want to look at the flip side of this story, the current disparities that I'm facing right now might have a long-term effect on the opportunities that I'll face in the future. And even worse, we know those disparities can arise very early in those pipelines. For example, in the education pipeline, we know that such disparities can arise at the preschool level. So then the question is going to be where to intervene to eliminate such disparities. And in this job market and education pipeline, we could try to intervene at the level of college admissions. But if we really believe that disparities start even in the preschool level, then maybe such an intervention is going to be too late. On the other hand, since disparities start very early in the pipeline, we could try to intervene at the preschool level. But one of the issues here is that it's going to be hard to control the downstream and the long-term effects of such an intervention. And that also we're not going to be able to prevent disparities further down the pipeline. So maybe a valuable approach here is to instead intervene at several levels of such a pipeline rather than myopically intervening at a single one. And then the question we want to ask is we want to understand how interventions at different stages of such a pipeline are going to compose. And we want to see how this understanding is going to inform the optimal design of interventions at several levels of such a pipeline so that we can improve outcomes and we can reduce disparities across groups. So our first contribution in this paper is to provide a theoretical and stylized model of such pipelines and of interventions on such pipelines. So we're going to represent our pipeline as a graph that is comprised of several layers, and individuals are going to be going through the layers of this graph. Individuals are going to start in a starting layer. And the starting layer is going to be comprised of several starting nodes, and each node is going to correspond to maybe a different starting subgroup or a different starting subpopulation. Then the individuals are going to go through the subsequent layers of this pipeline, and each layer of this pipeline is going to be representing a stage of life, and each node in a layer is going to correspond to the outcome of a given stage of life. So for example, you could imagine that the layer is going to correspond to college education or to being on the job market for the first time. And different nodes on this layer are going to correspond to different qualities of education or different types of degrees that someone is going to get. Finally, our individuals are going to reach a final layer. So they're going to reach a node on this final layer. And this node is going to have a reward, which is going to be a simple one-dimensional measure of the quality of the outcome that corresponds to this node. So now I've told you about the layers, but I haven't told you yet in our model how agents are actually moving between layers. And so we're going to assume that agents are moving probabilistically between layers. So we're going to have stochastic transitions between layers. And the stochastic transitions are going to govern the probability of going from a node, say, I on a layer to a node, j, on this next layer of our graph. And this is in those probabilistic transitions that we're going to model disparities in access to opportunities. What we can do here is we can give different groups, different starting populations, different probabilistic paths to different reward nodes throughout this graph. So in this kind of graph, our intervention model is going to be the following. We'll take the point of view of a centralized designer who can intervene at any and at several stages of this pipeline. And an intervention is going to consist into changing the stochastic transitions between layers. And our centralized designer is going to be constrained in the sense that he's going to incur a cost, or she's going to incur a cost to change transitions between two successive layers, and has a maximum budget that can be invested across all layers and transitions in the graph. Our second contribution in this paper is to give algorithms for linear optimal interventions. And so more precisely, we're providing dynamic programming algorithms for finding an approximately optimal budget split across the layers, and an approximately optimal way to use the budget to change the transitions between layers. And our algorithms are going to be efficient even when we have many layers, but they're going to require that each layer has a small or a constant width. And so we're going to do so for two objectives. The first one is we're going to try to maximize the social welfare or the expected reward of the total population, given a starting distribution over starting nodes over where individuals are going to start in the first layer. And this benchmark here is the best that can be achieved at the level of the whole population. But really, this benchmark does not say anything about each group. And so this benchmark may ignore minority or disadvantaged subpopulations. So to address this, we look at a different objective, which is a maximum objective, in which we're trying to maximize the welfare of the worst off group or subpopulation. And now this benchmark is actually guaranteeing that every group is going to get the highest expected reward that can be achieved at the same time for all subpopulations. So before concluding this talk, I just want to make a quick remark and point out a bunch of, I think, interesting future directions. So first, I would like to point out that we actually also show hardness results in this paper. And we show that it's NP hard to approximate an optimal solution of our problem to any constant factor in networks that have large width. And so that means our framework is going to be better suited to situations in which we can coarsely group the outcomes at every stage. And finally, I want to point out that this is still a very first step. This is still a very stylized and theoretical model. And in practice, there are many important directions that we're not taking into account here. Some of these directions are the following. So in practice, we know that early interventions have the ability not only to change the transitions at the moment we do these interventions, but also later in the pipeline. We can also imagine that the transitions are not necessarily going to be just probabilistic or stochastic, but they're going to involve strategic elements and agents in the pipeline making decisions about where they want to go. In our current model, we have an acyclic model, so we're not taking feedback loops into account, and I think it would be very interesting to do this in future work. We also have a simplified reward model which is one-dimensional, in which everyone wants the same outcomes. And finally, we have a model in which our designer is centralized, but it would be interesting to see what's going on when we have different entities that could be intervening at different stages of this pipeline. And so that's all I wanted to talk about today. So thanks for listening.